Let's take a look at example 3 now, where we find the derivatives. And in this problem, we're going to use the 4 rules that we learned all together. So we're going to use the sums and difference rules together with the constant rule, together with the constant multiple rule, and the power rule. So everything is going to be merged together. So we start with the first one. It says we want the derivative of the quantity 2x cubed minus 9 with respect to x. So I'll write all the steps for this one, but eventually we're going to start skipping some of the steps. So first of all, there's a minus in the middle, and the minuses don't matter. So we're going to do the derivative of the first part, we're going to do the derivative of the second part, and we're going to stick a minus in the middle because that's what was there previously. So that's the difference rule basically. Next, I have a constant being multiplied by a function. So I'm going to separate the constant from the function. So I'm going to pull the 2 out and put the x cubed inside the parentheses with the ddx in front of it, and then leave everything else alone. Once I've done that, the 2 is now on the outside and it's being multiplied with the derivative of x cubed. At this point, I'm going to have to use a couple different rules. First of all, for the x cubed, I have to use the power rule, which says bring the 3 down and then subtract 1. Now for the next part, we have a 9. The derivative of 9 is actually going to be just simply a 0. So the derivative of x cubed was the power rule and it gave me 3x squared. The derivative of 9, I used a different rule there. I used the constant rule to turn it into a 0 because it's a constant all by itself, unlike the 2 that was earlier in the beginning of the problem. That 2 has an x attached to it, whereas the 9 does not have an x attached to it. And notice how I kept the minus in the middle. And finally, once everything is done, 2 times 3x squared is going to be 6x squared. And that's the final answer in this question. I'm pretty much going to have to mimic the same steps in the next part. So let me start with that. It says derivative with respect to x, and we have a lot of terms. 34x minus the cube root of x plus the 6 over x squared, and then finally minus the 3. So again, I'm going to write down all the steps for this one, and ultimately I'm going to stop writing down the steps from this point on. But first of all, we are going to have 4 derivatives. One for the 34x, one for the cube root, and since I have a cube root and it's not convenient, I'm going to rewrite it right away as x to the power of 1/3 so that I can see what the power is. Same thing again with the plus, and then I have derivative with respect to x of 6x on the denominator. So I'm going to rewrite it with 6x to the power of -2 on the numerator. And then finally the derivative with respect to x of 3. So all I did here is make a couple of changes. First of all, I don't like this cube root, so I'm rewriting it. I don't like the x squared on the denominator, so I'm rewriting it right away. And I used the sum product rule to separate these problems from each other. So that way I could look at each one of them individually. Now, any constants are going to be extracted out. So 34 is going to be extracted out. The 6 is going to be extracted out. We're going to leave the x alone for now. We're going to leave the x to the 1/3 alone for now. The x to the -2 alone for now. And the 3, we're going to leave it alone for now. So at this point, all I'm doing is pulling the constants out. In order to do that, I had to use what's called the constant multiple rule. So at this point, we are ready to find derivatives. So first of all, the 34 is going to hang out. And now, looking at the derivative with respect to x of x, I can write down 1 because the derivative of x is always going to be 1. Then I have a negative, and next we have the derivative of x to the power of 1/3. That will be 1/3 x to the power of 1/3 minus 1, which is -2/3. And so again, the minus that was in the middle stays in the middle. Next, we have a plus, and we have a 6, and we're going to ignore the 6 out, and we're going to differentiate the x to the power of -2. So what is the derivative of x to the -2? Again, it's bring the power down, then subtract 1 from the power. So it's already -2, then I take away 1, it becomes -3. And notice that there is a multiplication between those two and the 6. Finally, the derivative of 3. The derivative of 3 is going to be 0. And again, because there's a minus in front, don't forget to write the minus in front of the 0. So that's basically the derivative. And notice how I don't write ddx anymore. It's gone. I just did the derivative. All I have to do is clean it up a little bit. So 34 at the beginning, negative 1/3, and I'm gonna rewrite it with a positive exponent, so that means I should put the x on the denominator. Then finally, plus 6 times negative 2 is going to be negative 12, and then again I have x to the power of negative 3, so I'm gonna rewrite it again on the denominator with a positive exponent. So that is my final answer at this point, and again the 0 gets ignored from the end. So pretty straightforward, it's not terribly difficult, it's just a lot of steps to keep track of. So let me show you how we're going to be doing these things without writing all the steps down in the last part. So derivative with respect to x of pi plus 2 square root of x minus 1 over x. So first of all, what I'm going to do is rewrite all the x's with exponents that have numbers. So instead of 2 square root of x, I'm going to rewrite it as x to the 1/2. So instead of the square root of x, we can write x to the 1/2. And also, instead of 1 over x, we can write x to the power of negative 1. Since the x on the denominator has a positive 1 exponent, we can rewrite it on the numerator with a negative 1 exponent. And now I'm going to pretend like I broke it down one by one in my mind. So I'm not going to write derivative of pi plus derivative of 2x to the whatever. I'm just going to do it mentally. And so next, what's the derivative of a pi going to be? Remember, pi is a number. The derivative of number is going to be 0. So I just write down the 0. The plus sign in the middle gets written down, again, gets recorded. And the 2 has an x next to it. So the 2 here gets ignored because it's kind of like a constant times a function. What I do next, though, is take the derivative of x to the power of 1/2. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. And again, it follows a minus next. So we're going to put a minus next. And then finally, x to the power of negative 1. What is the derivative of x to the power of negative 1? Well, again, bring the power down, then subtract 1 from the power, and it becomes negative 2. And so again, that's the answer without having to write down all the steps. All I have to do now is clean it up a little bit. So 0 is not going to matter. 2 times 1/2 is going to be 1, which I can ignore. So far it's x to the power of negative 1/2. Double negatives is going to make it positive 1 x to the power of negative 2. So again, I don't need to write down the 1. I could just write down x to the power of negative 2. That is the answer, but you can go one step beyond and write it as 1 over x to the 1/2 plus 1 over x squared. So make it positive exponents. And if you prefer radicals, you can always go 1 over square root of x plus 1 over x squared. So which one should you pick? This one or that one? Really, it does not matter. Just pick one of the three and write it down.